Hello, welcome to today's topic. This video is for anyone who is into artificial intelligence and machine learning because of the content that I'm going to go over is basically the various algorithms that are used in machine learning, and I'm going to try and explain them in a simplified way, each one. And I have created playlists already, and if you want to dig deeper into a particular topic for you. Also, I am enclosing inside the video's description box a link to my website, which is from an old website, so a detailed list of everyday videos that I make, that I have made, and take the viewing pleasure from there, because it's much easier. You can't show all the videos on the YouTube platform, so I've created a website where you can see anything you like at a click of a button. So the major focus will be on commonly used machine learning algorithms covered such as linear regression, logistic regression, naive Bayes, KNN, and random forest, etc. And how to what is the concept and the implementation of these algorithms in Python. So basically, a lot of these algorithms are being used in Google's self-driving cars, and robots get a lot of media press coverage. The technology that enables computers to get much more smarter and more personal is because of these algorithms. We are living in the most defining period of human history, the period when computing moved from large mainframes to personal computers, and now to the cloud. But what makes it defining is not what has happened, but what is coming our way in years to come, which is the defining moment of artificial intelligence. Today, as a data scientist, we can build data crunching machines with complex algorithms for a few dollars per hour, but reaching this goal is not easy. Maybe you're a beginner looking for a place to start your data science journey. Presenting a comprehensive list of courses, a full knowledge of data science learning curated for you to learn data science using Python from scratch. Who can benefit the most from this video? The idea behind creating this video is to simplify the journey of aspiring data scientists and machine learning enthusiasts across. Through this guide, I will enable you to work on machine learning problems and gain from experience. And I'm going to provide understanding of various machine learning algorithms with Python codes to run them. That should be sufficient to get your hands dirty coding. Broadly speaking, there are three types of machine learning algorithms. Number one, supervised learning. How it works: the algorithm consists of a target, outcome variable, or a dependent variable, which is to be predicted from a given set of predictors, independent variables. Using these set of variables, we generate a function that map inputs to desired outputs. The training process continues until the model achieves a desired level of accuracy on the training data. Examples of supervised learning are regression, decision tree, random forest, KNN, logistic regression, etc. Number two, unsupervised learning. How it works: in this algorithm, we do not have any target, outcome, or variable to predict estimate. It is used for clustering population in different groups, which is widely used for segmenting customers in different groups of specific intervention. Examples are unsupervised learning is a priori algorithm, K-means, etc. Number three, reinforcement learning. How it works: using this algorithm, the machine is trained to make specific decisions. It works this way: a machine is exposed to an environment where it trains itself continually using trial and error. The machine learns from past experiences, tries to capture the best possible knowledge to make accurate business decisions, Examples of reinforcement learning are Markov decision process. And now here are the common machine learning list of algorithms. Number one, let's go through them one by one, shall we? Linear regression. It is used to estimate real values, cost of houses, number of calls, total sales, etc. based on continuous variables. Here we establish relationship between independent and dependent variables by fitting a best line. The best fit line is known as a regression line and represented by a linear equation y is equal to a times x plus b. And here is the chart. Linear regression is mainly of two types, simple linear regression and multiple linear regression. Simple linear regression is characterized by one independent variable, and the multiple linear regression, as the name specifies, is characterized by multiple more than one independent variables. While finding the best fit line, you can fit a polynomial or curvilinear regression, and these are known as polynomial and curvilinear regression. Linear regression is a supervised learning algorithm. We find target value based on independent predictors. The output is continuous in nature. We simply find the line that best fits the data on the graph. Now let's talk about logistic regression. Don't get confused by the name. It is a classification. It's a classification, not a regression algorithm. It is used to estimate discrete values, binary values like 0 and 1, yes and no, true and false, based on a given set of independent variables. So that's why it's called logistic regression. In simple words, it predicts a probability of occurrence of an event by fitting data to a logic function. Hence, it is also known as logic regression, since it predicts a probability. Its output values lies between 0 and 1. And here's the chart to go with the logistic regression. And just to add to logistic regressions, there are some furthermore steps that could be tried in order to improve the model, including interaction terms, removing features, regularization techniques, and using non-linear model. I thought I just mentioned that. Logistic regression is also a supervised learning model. The category is classification. Similar to linear regression, but it is used to model the probability of finite number of outcomes. Typically, the output values can only be between 0 and 1. And the next model is the number 3 decision tree. This is one of the favorite algorithms that we can use quite frequently. It is the type of supervised learning algorithm that is most used for classification problems. Surprisingly, it works for both categorical and continuous dependent variables. In this algorithm, we split the population into 2 or more sets. This is done based on most significant attributes, independent variables, to make distinct groups as possible. And here's a chart to go with it. The most famous example, if you're doing a course in artificial intelligence, the decision tree of the Titanic ship that sunk is most famously used to elaborate this model. Decision tree can be either a classification or a regression model depending on the problem given. A decision tree is a flowchart-like diagram that shows the various outcomes from a series of decisions. It can be used as a decision-making tool for research analysis or planning strategy. The primary advantage of a decision tree is that it's easy to follow and understand. The problem. And number 4, the SVM, which is Support Vector Machines model. It is a classification model. In this algorithm, you plot each data item at a point non-n-dimensional space where n is the number of features you have, with the value of each feature being the value of a particular coordinate. So, for example, if we had only two features like height and hair length of an individual, we'd first plot the two variables in two-dimensional space, and where each point has two coordinates. These coordinates are known as support vectors, as in this chart. Now we will find some line that splits the data between the two differently classified groups of data. This will be the line such as distances from the closest point in each of the two groups will be the farthest away in the next chart. In this example shown above, the line which splits data into two different classified groups is the black line, since two closest points are the farthest from the line. This line is our classifier. Depending on where the testing data lands on either side of the line, that's what class we can classify as the new data. Support vector machine can also be used for classification as well as regression problems. Are used for classification problems in machine learning. Support vector machine can be used for two group classification problems. After giving an SVM model sets of label training data for each category, they are able to categorize new text. A technique that can carry an objective to find a hyperlink in n-dimension space that can distinctly classify data points. And the next model we're going to talk about is number 5, naive Bayes. It is a classification technique based on Bayes' theorem with the assumption of independence between predictors. In simple terms, naive Bayes classifier assumes the presence of particular features in a class. It is unrelated to the presence of any other feature. For example, fruit may be considered to be an apple if it is red color and round and about 3 inches in diameter. Even if these features depend on other or upon existence of other features, naive Bayes classifier would consider all of these properties to be independently contribute to the probability that it is a fruit of the type apple. Naive Bayesian model is easy to build and particularly useful for very large data sets. Along with simplicity, naive Bayes is known to outperform even highly sophisticated classification methods. The Bayes theorem provides a way of calculating posterior probability, which is PCX from PC, PX, and PXC. Look at the equation below. Over here, PCX is the posterior probability of class target given a predictor attribute. PC is the prior probability of the class, and PXC is likelihood, which is the probability of predictor given class, and Px is the prior probability of the predictor. Naive Bayes classifier is one of the simple and most effective classification algorithms, which helps in building the fast machine learning models that can make quick predictions. That means it's a probabilistic classifier, which means it predicts on the basis of the probability of an object. In the next model, number 6, KNearest Neighbor. It can be used for both classification and regression problems. However, it is more widely used in classification problems in the industry. KNearest Neighbor is a simple algorithm that stores all available cases and classifies new cases by majority vote of its k-neighbors. The case being assigned to the class is the common amongst its k-nearest neighbors, measured by distance function. These distance functions can be Euclidean, Manhattan, Minkowski, and Hamming distance. First three functions are used for continuous functions, and fourth one is Hamming for categorical variables. If k is equal to 1, then the case is simply assigned to the class of its nearest neighbor. At times, choosing k turns out to be challenging while performing KNN modeling. An introduction to KNearest Neighbor simplified. Have a look at this chart. KNN can easily be mapped to our real lives. If you want to learn about a person of whom you have no information, you might like to find out about his closest friends and the circles he moves in and gains access to his or her information. Things to consider before selecting KNN. KNN is a computational expensive. Variables should be normalized, else higher range variables can bias it. Works on pre-processing stage more before going for KNN, like an outlier noise removal.
KNearest Neighbor is a supervised machine learning algorithm. The algorithm can be used to solve both classification and regression problems. The number of nearest neighbors to a new unknown variable that has to be predicted or classified as denoted by the symbol K.
Let's look at number 7, k-means. It is a type of unsupervised algorithm which solves the clustering problem. Its procedure follows a simple and easy way to classify a given data set through a certain number of clusters, assuming k clusters. Data points inside a cluster are homogeneous and heterogeneous to peer groups. Remembering, figuring out shapes from ink blots, k-means is somewhat similar to this activity. You look at the shape and spread the decipher how many different clusters are derived from that shape, population, or such as in this chart. How k-means forms cluster. Now, k-means picks a k number of points from each cluster known as centroids. So the centroids are selected from the number of points of each cluster has. They pick one centroid from that cluster. Each data point from a cluster with the closest centroid finds the centroid of each cluster based on existing cluster members. Then we have new centroids. As we have new centroids, repeat steps 2 and 3, find the closest distance of each data point from the new centroid and get associated with the new cluster. Repeat the process until convergence occurs, i.e., explanation centroids does not change. How to determine the value of k? In k-means we have clusters and each cluster has its own centroid, sum of square of difference between centroid and the data points. So the centroid versus the data points, they calculate the distance between each. Also, when the sum of square values of the clusters and added, it becomes total within sum of squared value for the cluster solution. We know that a number of cluster increases, this value keeps on decreasing, but if you plot the result, you see the sum squared distance decrease sharply to the sum value of k, and then much more slowly after that. Have a look at this chart.
K-means is a technique for data clustering that may be used for unsupervised machine learning. It is capable of classifying unlabeled data into predetermined number of clusters based on similarities, which is the K.
Number 8, random forest. Random forest is a trademark term for an ensemble of decision trees. In random forest, we've collected decision trees, so known as a forest. To classify a new object based on attributes, each tree gives it classification, and that they are known as votes of that class. The, the forest chooses the classification having the most votes over all the trees in the forest. Each tree is planted and grown as follows. Number 1. If the number of cases in the training set is n, then sample of n cases taken at random but with replacement. The sample will be training set for growing the tree. Number 2. If there are m inputs, variables number m less than m is specified such that each node m variables are selected at random out of m, and the best split on these m is used to split the node. The value of m is held constant during the forest growing. Number 3. Each tree is grown to the largest extent possible. There is no pruning.
Random forest is an assemble learning technique that builds off decision trees learning using bootstrap datasets for multiple decision trees of original data and randomly selecting a subset of variables at each step of a decision tree. Basically, a bunch of decision trees. Random forest is a supervised machine learning algorithm. The algorithm is applied in various industries such as banking and e-commerce to predict the behavior of outcomes.
And the next example is number 9, dimensionality reduction algorithms. In the last 4 or 5 years, there has been exponential increase in data capturing at every possible stage. Corporates, government agencies, and research organizations are not only coming with new sources, but they are also capturing data in great detail. For example, e-commerce companies are capturing more detail about the customers, like their demographics, web crawling history, and also what they like and dislike on your browser, purchase history, feedback, and many other examples. The personalized attention more than your nearest grocery store keeper. As data scientists, the data we are offered constant. This sounds good, but for building a robust model, but there is a challenge. How do you identify highly significant variables out of 1,000 or 2,000? In such cases, dimensionality reduction algorithm helps us along with the various other algorithms like decision tree, random forest, PCA, factor analysis, identified based on correlation matrix, missing values ratios, and others.
Dimensionality reduction. By reducing the number of input features, thereby reducing the number of dimensions in the feature space. Hence, to make a long story short, dimensionality reduction means reducing your feature sets in dimensions. A process of reducing dimensions of your feature set, either categorized as feature elimination or feature extraction. A popular method is principal component analysis, PCA.
And the next example is number 10, gradient boosting algorithms. GBM. GBM is a boosting algorithm used when we deal with plenty of data to make prediction with high prediction power. Boosting is actually an assemble of learning algorithms which combine prediction of several base estimators in order to improve robustness over a single estimator. It combines multiple weak or average predictors to build a strong predictor. These boosting algorithms always work well in data science competitions like Kaggle, AB Hackathon, crowd analytics.
Gradient boosting algorithms. These are the super preprocessor fast algorithms. There are 4 types. In the last 20 years, they have been used extensively. Gradient boosting algorithms are supervised machine learning algorithms used for classification and regression problems. As we know that the errors in machine learning algorithms are broadly classified in two categories: bias error and variance error. As gradient boosting is one of the boosting algorithms, it is used to minimize bias error of the model.
And a sub part of the same model is XGBoost. Another classic gradient boosting algorithm is also known as decisive choice between winning and losing in some Kaggle competitions. The XGBoost has an immensely high predictive power, which makes it best choice for accuracy in events as it possesses both linear model and trilinear algorithm, making the algorithm almost 10 times faster than existing gradient boosting techniques. So it speeds up the processing of the model. That's why this XGBoost is a really good model. The support includes various objective functions including regression, classification, and ranking. One of the most interesting things about XGBoost is that it's also called a regularized boosting technique. This helps to reduce overfit modeling and has a massive support for a range of languages such as Scala, Java, R, Python, Julia, and C++. Distributed and widespread training on many machines that encompass GCE, AWS, Azure, Yarn clusters. XGBoost can also be integrated with Spark, Flink, and other cloud data flow systems with a built-in cross-validation at each iteration of the boosting process.
XGBoost algorithm stands for extreme gradient boosting. XGBoosting is optimized distributed gradient boosting library designed to be highly efficient, flexible, and portable.
And another sub model within the gradient boosting is LightGBM as a gradient boosting framework that uses tree-based learning algorithm. It is designed to be distributed and efficient with the following advantage. It is faster training speed with higher efficiency, lower memory usage, better accuracy, parallel and GPU learning supported, capable of handling large-scale data. The framework is fast enough and high-performance gradient boosting one based on decision tree algorithms used for ranking, classification, and many other machine learning tasks. It was developed and distributed under the Distributed Machine Learning Toolkit project of Microsoft. Since the LightGBM is based on a decision tree algorithm, it splits the tree leaf-wise with the best fit, where other boosting algorithms split the tree depth-wise or level-wise rather than leaf-wise. So when growing on the same leaf in LightGBM, the leaf-wise algorithm can reduce more loss than the level algorithm and hence results in much better accuracy, which can rarely be achieved by any of the existing boosting algorithms. And it's surprisingly very fast also.
LightGBM, Light Gradient Boosting Machine Learning Algorithm, is a gradient boosting framework based on decision trees to increase the efficiency of the model and reduces memory usage, hence the use of preprocessor algorithms.
Finally, another sub model of the gradient boosting is CatBoost. It is a recently open source machine learning algorithm from Yandex. It can easily integrate deep learning framework like Google's TensorFlow and Apple's Core ML. The best part of CatBoost is that it does not require extensive data training like other machine learning models and can work on a variety of data formats, not undermining how robust it can be. Make sure you handle missing data well before you proceed with this implementation. CatBoost can automatically deal with categorical variables without showing the type of conversation error, which helps you to focus on tuning your model better rather than sorting out trivial errors.
And finally, there is the CatBoost. It is easy to use and works well with heterogeneous data and even relatively small data. It is essentially creates a strong learner from an ensemble many weak learners. CatBoost or categorical boosting is an open source boosting library developed by Yandex.
And finally, projects. You have to do these projects in order to get your hands experienced with each of these models. The more practice, as in mathematics, you have, the better you understand them. By now, I am sure you have an idea of commonly used machine learning algorithms. The sole intention behind the video is providing the knowledge and the concept that should get you started right away. And as always, if you like the video, click the like icon, and if you want to see more of the videos, click the red button. And check out my other artificial intelligence videos. Ta-da from Shazzy. Enjoy this video? Then must have a look at these videos.